This is Todd Frazee, and this is the video tutorial for modeling the slide stop, part number 7312, Rev 0, for the vice stop assembly. And we'll be modeling this in Fusion. Okay, so it's this kind of rectangular part. It has a auxiliary view. So an auxiliary view means that that view is projected at an angle normal to the line that says BB on here. That way you have a true view of the distance of this hole straight on, and you can measure the distance from the center of that hole to the flat that we're looking straight on at, this 45-degree flat. So those features were put in there intentionally so that the flat we have here on the bottom can rest on the parallels or the bottom of the vise, so that this face that's parallel to it is facing the spindle, and we can edge find or put a stop on this edge I've got my mouse going over as our reference for this 73 thousandths and accurately drill this hole at a compound angle. Okay, so we're going to start modeling this. We're going to start with the outside shape, and then we'll incorporate the rectangular hole in the center in that, and then we'll extrude this all the way through. Okay, and then we'll go back and we'll put the 3 holes in it, and that should pretty much wrap up the modeling of this. So we're going to start with sketching it as if it's in this front view here in Fusion. So go ahead and open a Fusion file, and first thing again you want to save. We're going to call this the 7312 Rev 0 underscore your first initial last name, and save. Okay, so we're going to do a sketch. We typically want to put it in the same view as the drawing, so that's front view. And on this part, we're going to start with a line. We're going to start with origin. We're going to go up. We're going to go roughly at 45 degrees, go horizontal, another 45, go vertical, one more 45, which should end in line with the bottom of the part, and back to origin. So you should have this rectangle that has 3 of the 4 corners knocked off on it. Okay, now we also have a rectangle on the inside. So we can go ahead and draw a rectangle, and then we're going to work on this as kind of a donut extrusion. Okay, let's put some relationships in first. We know this flat, and this flat are all equal in size. So we're going to highlight each of those, and we're going to make them equal in length. Now that doesn't mean the angle is equal, it just means in length they're equal. And the next thing we want to do is we want to dimension the angle on here. So we go from the angled line to vertical and drag our cursor up, click, and it's 45 degrees. Well, that was an unexpected result. That's okay. If you get that, all you gotta do is drag your endpoints so you get back to having a chamfer. Alright, let's put some more relationships in. Okay, so this bottom corner of the chamfer on the left and the bottom corner of the one on the right should be aligned horizontally. Okay, that forces that relationship. Okay, so I've got these 2 corners vertically aligned. These lines are all, these 3 lines for the corners are equal in length. This one's 45 degrees. All right, now let's go and look at our rectangle here in the center. Our dimensions on it, which it looks like we have some dimensions missing. The design intent was that this rectangular cutout is centered on the width and the height of this feature. Unfortunately, that wasn't put on the drawing. There should be a center line going in both directions, or a dimension floating that. So that will be fixed in Rev 1. But since I designed it, I'll do the executive decision to redline this. So this shape here should be the size we have here, but centered between the top and bottom. So if we go back to Fusion, we can set up at least that relationship. There's a variety of ways you can do it. I'm going to use a set of lines. So if I pick up on the midpoint of the top of the part and then the midpoint of the rectangle, I can then take that line and I can force it to be vertical, and then I can also make it construction. So now I have it centered right to left. Now let's do the same thing to make it centered up and down. So if I come from the center of one of the vertical walls and go to center of the vertical side of the part, remember that triangle symbol needs to appear. And now I have a line connecting the center points, and I highlight that line, click on with the right mouse button, turn it into a construction line, and then force it to be horizontal. I've now forced this box, no matter what size it is, has to be centered between those spaces. Okay, now our chamfer size. If we look at our drawing, it says that it's a 3 times 0.32 from the on one leg of the 45. Okay, so we're going to do that. So we go from the base line to the top edge of the fillet. We're going to click and we're going to put in 0.32. Okay, and that sets the size of the chamfers on the corner. And if our relations are set up, they should automatically all change with those two dimensions. Guess I could have thrown the 45 down here on the bottom just like it was on the drawing, but that's okay. The associations are there. Alright, now dimensions wise, we're going to put a dimension from the base of the part to the height, and on our drawing that is 1.95. Okay, and then our width is 0.36. Okay, so now we've crushed our outside perimeter. It looks approximately the size it's supposed to be. Our rectangle in the middle is smaller, but that's okay. It'll get corrected when we make our adjustments. So I'm going to hit the escape key to get out of the dimension command, and then we're going to drag the box a little bit wider and maybe a little bit taller. And we're going to put the fillets on the corners of the part. And you're probably going to generate an error because we have the center line feature here, but it should work if you do them all in the same instance and you're consistent. Alright, so we look at our drawing, and we actually have a bit of a tight tolerance on those. This is a slip fit for the pivot arm, and so we're holding this pocket to a pretty tight tolerance and includes the radiuses on the corners. What you want to do is model the box size to be nominal, so it's halfway between these two numbers. That way when you machine it, hopefully in theory you're starting off with zero compensation, and then you can compensate it if you need to. Alright, so if we were to take that first radius here and we were to subtract the smaller number from the bigger number, which is 0.2 0.214 minus 0.2, so 0.214 minus 0.214 minus 0.207 gives us 7 thousandths. You divide that number by 2, that gives us 3.5 thousandths. We add that to the lower number, 0.207, and that gives us halfway between these two numbers. So this is what we want to model our radius at, is 210 thousandths 5/10, and that gives us split right in the middle of the tolerance. So we're going to take that number and we're going to go back to Fusion, and we're going to make a fillet, and we're going to pick on these two corners, and if you use the calculator you put paste to put the number in. What we want to do is keep going here, because you notice we got an error down at the bottom, and we want to make sure we do all these at the same instance and the same size, because we have these center line relationships here. Now we need to put our dimensions on the width and height. So let's do the width first. We're going to go back to our drawing. Okay, so we have this range again. So actually let's do the height because the numbers are the same. So this radius is the same spread as the decimal equivalents on this dimension. So we can take our calculation we did here and use it for this number. So it's basically plus 1 inch. Okay, so let's add an inch. And the nominal halfway between 1 inch 214 and 1 inch 207 should be 1 inch 210 5/10. Let's go to copy. We're going to go back to Fusion. We're going to throw our height dimension on here. Control V from the calculator, throws our number in, and we've now set the height of the rectangle. It does appear that we've broke the relationship with midpoint. So we're going to need to reestablish that here. This is no longer on the midpoint of this line, and I don't know if the other one isn't. So when we put the fillets in, it broke that relationship. So in retrospect, make the fillets first, and then put these relationships in to center. Okay, not a big deal. We can fix it. We just have to notice it. Now on our width. Okay, we go back to our drawing, pull up our calculator. The width is this number here. So we have 0.764 minus 0.757. That gives us 7 thousandths. We're going to divide that by 2. That's 3.5 thousandths, and we're going to add it to the smaller number, 0.757. So our nominal is halfway between is 0.7605. You can copy that number either manually or with the calculator. And we're going to go back to Fusion, and that is our width dimension. I'll put that there, and Control V, enter. And yes, we're off center again. Not a problem. What we do is we're gonna click the end of our line, hidden line. We're gonna click the horizontal line, and we're gonna snap at the midpoint. We're gonna do the same thing with our side, and now this is now centered within our feature. If we look at our sketch, it's fully constrained. We've got that pretty well dialed in. Now, if you're having trouble with this much in the sketch, you can feel free to do, say, the outside feature first, and then come back and make the rectangular hole is a cut after the fact. I'm doing it all in one shot. Okay, so we're going to hit finish sketch. We're going to do an extrusion. We're only going to pick the one zone. We're going to leave the center empty. And the width of our extrusion is 0.75. And I like to rotate it to a 3D view. So we get this part that looks, I don't know, like an O or D. And let's hit OK. All right, so we have the base shape. Now we just have some holes to put in it. All right, so first we're going to put, there's a hole on the left side view in the drawing. It goes all the way through the part. It is a tight tolerance hole. We're going to drill this and then we're going to ream it. Okay, so then we have a countersink at the top. And on the back side is just going to be covered by the general edge break. Okay. So let's go ahead and model this. So it's nominally a 1/4 inch slip fit for a 1/4 inch rod that's going to go in there. All right, so let's go back to our model and let's place that feature. Okay, I'm going to go sketch. I'm going to pick on the side of the part. This time I'm going to use the hole wizard. So I'm going to pick and I'm going to create a point. We're going to put that point on the face. Now this hole is centered across this face, so we can create a line that goes from midpoint of the edges and is constrained vertical. And we're going to turn that line into a construction line. And we're going to take the point and we're going to highlight both the point and the construction line by holding the shift key down, and we're going to make them coincident. Okay, and then now we have a distance from the center of this hole to the bottom of the part, and it was 190 thousandths, so 0.19. Let's double check that. Yeah, it's 0.19. Yeah, both holes share that dimension. They're dimensioned on both views, so that means you don't have to hold them to each other. You know, they can vary by the tolerance on both of those and still function. Alright, so we have a 251 to 252 hole with a 90-degree chamfer at the top. Okay, so we're going to hit finish sketch. We're going to go to the hole command. We're going to pick the sketch plane and we're going to move our hole to the center of the point we made. Our hole type is going to be a countersunk hole. It's going to be a simple hole. Its diameter was supposed to be down in this box below, and the countersink is 0.3. It's bigger, but it's not real big. It's not a countersink for a fastener. It's just really an edge break lead-in. Okay, and then our distance is going to be through all. We're going to go all the way through the part. Okay, so we've got a 300 thousandths diameter countersink, 90-degree angle on a hole that's 251 thousandths 5/10 in diameter. That's it, okay? Okay, that goes all the way through. If we look at the other side, it exits out this side.